Question number 24. You can see a diagram there. Mass of the object is given 0.04 kilogram. Mass 0.04 kilogram. Now, what is the magnitude of impulse and what is the time between two consecutive impulse? Impulse means a strong force acting for a short interval of time. Due to strong impulse, what happens? The direction will change. So here you can see the velocity. This is a position time graph. Here unit is centimeter, that I only got to note very clearly. Here velocity is positive, then suddenly it becomes negative. That means the velocity changes its direction. At 2 seconds, at 4 seconds again velocity becomes positive. That means after every 2 seconds, velocity changes its direction. What is the reason for change in velocity? We have to consider there is an impulse. That is why. So therefore we can conclude the time between two consecutive impulses t is equal to 2 seconds. T is equal to 2 seconds. First answer you will get. Now what is the magnitude of each impulse, for which we have to calculate the velocity? You can calculate the velocity by taking the slope. When you take the slope, you have a y segment. Here on slope you have to take like this. So y segment is 2 into 10 power minus 2 centimeter. You have to convert to meter divided by x segment 2. So you will get a velocity is equal to 10 power minus 2 meter per second. Now impulse formula, impulse is equal to p2 minus p1. Okay, I is equal to p2 minus p1, and the velocity, magnitude of velocity will be same in all these cases. So we can take it as minus mv because direction changes, minus mu it is, but at the same time you have to understand that v and u are equal. Only difference is in sign. So minus 2 mv. So substitute the value of m and v, you will get the answer for impulse. Okay. Now, question 25. Okay, diagram is given. The conveyor belt is accelerating at 1 meter per second square. Acceleration is given. That's acceleration of the belt 1 meter per second square. What is the net force on the man? What's the net force? He's standing there. His gravitational force is cancelled by the normal reaction. So that force you can calculate using the formula F is equal to ma. And his mass is given 65. A is 1. So net force will be 65 Newton. Then the coefficient of static friction is 0.2. That also given in the question. Yes. Coefficient of static friction means it is a limiting friction. Maximum value of friction is 0.2. Up to what acceleration of the belt can the man continue to be stationary there? Okay, let's calculate how much is friction there. Friction is equal to mu r is equal to mu mg. Substitute the value of mg and mu. Okay, so you will get the friction, and that friction, how much will be the acceleration? That's what we need to calculate. Equate to ma, net force. You can simplify and substitute the values. So you will get acceleration a is equal to mu g is equal to, you will get approximately 2 meters per second square. That means the frictional force can give him an acceleration around 2 meter per second square. When the belt is accelerating in one direction, friction is acting in the opposite direction. And in opposite direction, friction is capable of giving 2 meter per second square acceleration. And his current acceleration is in the forward direction only 1 meter per second square. So no problem, he will stand there. Suppose the acceleration of the belt is more than 2 meter per second square, then the friction is not able to keep the man on the belt. So what will happen? He will fall. So for what maximum acceleration friction is able to hold him there, it is 2 meter per second square. Up to the belt acceleration, 2 meter per second square, the man will remain standing there. Okay, then next. Question 26. A stone of mass m tied to the end of a string and revolves in a vertical circle of radius r. The net force at the lowest and highest points of the particle directed vertically. Okay, net forces. So vertical circle we have discussed already. So the vertical circle. So the string and the object is here. Tension is acting downward, which you can take as T2. Mg is also acting downward. Then, when the object is at the lowermost point, then Mg is acting downward. But so far the object is in circular path. The tension T1 is acting upward. So look at there, lowermost point, then tension is acting upward. Okay, tension is acting upward. So lowermost point, Mg and T1 are in the opposite direction. So net force towards the center is Mg minus T1. Net force towards the center is Mg minus T1. And here net force towards the center is Mg plus T2. Therefore, option A is the correct answer. Then next question 27. I think I have explained already. Helicopter 1000 kilogram mass, acceleration 15 meter per second square, vertically upward. The crew and passengers of 300 kilogram give the magnitude and direction when force on the floor by the crew and passengers. Okay, so force is equal to m into g plus a, and m you have to take as 300 now because it is because of crew and passengers, and this force is acting downward. Next, action of rotor on the helicopter. So action on the rotor over air should be able to lift the entire object. Therefore, we can have the answer again m into g plus a as it is moving upward, m into g plus a. But this time, m you have to take 1300 kilogram. 1300 kilogram, and the rotor, the fan of the helicopter, will apply force over the air downward. Then force on the helicopter due to surrounding air. So when this much force is applied over the air gives equal and opposite force, third law. So how much it is? Same as that of m into g plus a. The only difference that force will be acting upwards on the helicopter. So That's the answer to 27. Now, next question 28. So, a stream of water horizontally with the speed 15 meter per second. So, speed of water is given 15 meter per second. Gushes out of a tube of cross-sectional area 10 power minus 2 meter per second square. Area is given. It hits a vertical wall nearby. What is the force exerted on the wall by the impact of water, assuming it does not rebound? That means what is its final velocity? Final velocity is 0. Okay, U is equal to 15 meter per second, and area A is equal to 10 power minus 2 meter square. Okay. Now, first of all, suppose we multiply area into velocity. Area into velocity. I'm going to write the corresponding units. Area unit is meter square. Velocity unit is meter per second. So when you multiply, you will get meter cube per second. So what is that unit meter cube per second? Meter cube per second means volume per second. So whenever you multiply area and velocity, you will get volume per second. So we will start from there. Volume per second is equal to area into initial velocity you have to take. Therefore, we can write U. Area into velocity will give volume per second. Then next, mass per second is equal to, you have volume, you can find mass by multiplying with the density. Will give a mass per second. Now, force we have to calculate. Force is equal to mass into acceleration, v minus q by this formula. We can just rewrite like this: m by t into v minus u. Then what is m by t? M by t is mass per second. Mass per second is AU rho. Therefore, this is equal to AU rho into V minus U into V minus U. All quantities are given. Area is there. Initial velocity U is 15. Density of water is 1000. Density of water is 1000 kilogram per meter cube. Then V, final velocity V is 0. So substitute the values and find the answer. Okay. Now, next question 29. 10 1 rupee coins are put on the top of each other on a table. Each coin has a mass here. Give the magnitude and direction of the first question. The force on seventh coin due to all other coins. Force on seventh coin. Okay. Suppose we have the pile of coins like this. So 10th coin, 9th coin, 8th coin. So this is the 7th coin. So 1, 2, 3. 3 coins are there above the 7th coin. So what happens? Each one having mass here. So 3 coins are there. So on the 7th coin, each coin will apply a force mg. There are 3 coins above the 7th coin, so 3 mg acting downwards. Then the force on 7th coin by the 8th coin. The force on 7th coin by 8th coin, above 8th coin, 2 more coins are there. So that also will be 3 mg down. Because above 8th coin, the other 2 coins are there. Now next, the reaction of 6th coin on the 7th coin. Above 6th coin, 4 more coins are there. So these 4 coins will act a force 4 mg downward on 6th coin. 4 mg downward on 6th coin. So 6th coin will give a reaction 4 mg upwards. Therefore, third answer will be 4 mg as it is reaction acting upwards. 4 mg upwards. Then next, question 30. An aircraft executes a horizontal loop of 720 km per hour, which you need to convert into meter per second. And its wings banked at 15 degree theta. Angle of banking theta is given. What is the radius of the loop? Okay. So use the formula V is equal to under root Rg tan theta. V is equal to under root Rg tan theta. Then square the equation, then find the value of R. Value of tan theta you have to find out from the tangent table. Then next, question 31. A train runs along an unbanked circular track of radius 30 meter. R is given 30 meter. With a speed of 54 km per hour, again you have to convert into meter per second. Mass of the train is 10 power 6 kilogram. Okay. What provides the centripetal force required for this purpose? Engine or the rails? So centripetal force. Centripetal force is given by friction. Friction is obtained from rails. So the answer is rail. Rail will give the necessary centripetal force. Then, what is the angle of banking required to prevent the wearing out of the rail? Again, use the same formula, angle of banking you have to calculate, which means you have tan theta. Same formula which you have used in the previous problem, tan theta is equal to V square divided by R. R is given, V is also given, so you can find the value of tan theta, then you can find the value of theta from the table using tangent table. Now, next question 32. A block of mass 25 kilogram is raised by a 50 kilogram man in 2 different ways. Diagrams are given there. Then what is the action on the floor by the man in 2 cases? If the floor yields to a normal force 700 Newton, maximum capacity of the floor is 700 Newton, which mode should the man adopt to lift the block without the floor yielding? Okay. So I'm going to take a, for 10 minutes, I'm going to take a G is equal to 10 meter per second square. G is equal to 10 meter per second square. Now see here, 25 kilogram weight. Its weight is acting mg downward. So 250 Newton downward. 250 Newton downward. Then if the man wants to lift the object, minimum how much force he needs to apply? He needs to apply 250 Newton upward. To lift the object, 250 Newton force has to be applied upward. When he applies an upward force 250 Newton, Okay, how much will be the reaction he is applying on the floor? The reaction will be 250 Newton. If he applies a force 250 Newton on the floor, then only he can apply a force 250 Newton to lift the object, action and reaction. Now, again, question says that uh, his mass is 50 kilogram. So, how much is his body weight? His body weight will give again mg, that is 500 Newton. Therefore, what is the total action on the floor? It is 250 plus 500. So 750 Newton is the total action on the floor in case 1. 750 Newton. Now come to case B. Again 250 Newton downward. The weight of the block. He has to apply here 250 Newton upward. But the difference, what is the difference? He is using a pulley now. So he is pulling down. Instead of lifting the object, he is pulling down. Here he needs to give 250 Newton. That is downward. When he applies a force downward 250 Newton, then what about the reaction on the floor? The reaction on the floor will be then 250 Newton upward, because this is the action here. So 250 Newton upward. Then 250 Newton upward, and his weight is acting 500 Newton downward on the floor. So what is the total force acting on the floor now? The total force acting on the floor is 500 minus 250. So you will get 250 Newton. So the total action on the floor is 250 Newton now in second case. While in first case it is 750 Newton, and question says that the floor can sustain maximum 700 only. Therefore, which one of these options you have to select? Of course, it is second option, otherwise the floor will collapse. Now, question 34. Question 33 we have discussed already. So question 34. Okay, two bodies A and B, 10 kilogram. A is 10 kilogram. A 5 kilogram. B 10 kilogram. Coefficient of friction is 0.15. A 200 Newton force. Everything is clear from the diagram. A 200 Newton force is applied horizontally. There is a rigid wall is there, so that absolutely there is no movement possible. So what happens then? What are the reaction of the partition and action reaction forces between A and B? Okay, so between A and B, so 204 Newton force is applied here. So object A applies a force 200 Newton on B. B gives opposite reaction. So there is no scope of any movement there. Okay, there is nothing for the friction. So action, reaction, everything will be answer to A, answer to B, all these will be 200 Newton only. Okay, all these answers you will get 200 Newton for answer to A and answer to B. Now the third part we have to take. What happens if the wall is removed? When the wall is removed, so what will be the situation? Okay, when the wall is removed, the objects A and B begins to move. As the object A and B begins to move, what will happen? That is what we have to think next. First of all, we can calculate the total friction. Total friction in the sense of friction acting on A and B. Total friction is equal to mu mg. For the time being, you take a G10. When you take total friction, M, you have to take a 15 kilogram. 15 kilogram you have to take. So that will be the total friction. Then, what is the net force acting? Okay, F net. Net force is equal to already applied force 200 Newton is there. Okay, applied force 200 Newton minus friction mu mg divided by total mass m will give a net force. Sorry, Fa minus mu mg will give a net force. Okay, you will get a net force Fa minus mu mg. Now you can calculate acceleration. Acceleration of the objects A is equal to F net divided by M. Again, I remind you, M you have to take 50. So you got acceleration of the object. Okay. Now next we consider how much friction is acting on object A. Only object A we consider. Friction on A. Friction on object A is equal to again mu mg, but mass of object A you have to take. So you have to take a mu mg A. Mu mg of object A. Okay. Now, what are the uses of 200 Newton force applied on the object? You know, the objects are moving with an acceleration A now. So what are the uses of the applied force? So the applied force 200 Newton, I will write Fa 200 Newton, applied force 200 Newton. Okay, it is applied on force A. So object A will use this force to overcome its friction. So the friction acting on A, to it is this applied force is used to overcome friction, plus it is used to give a force on B, force applied force applied by force applied by object A, force applied by object A on B. We can write it as FAB, plus to give the net force. How much is net force on A? Mass of A into acceleration. So the applied force 200 Newton is used for three uses. What are the three uses? To overcome friction on A. At the same time, A gives a force on B, that is FAB, plus the net force for the motion, that is mass of A into acceleration A. Now here friction on A you have, acceleration you have, acceleration, so friction you know, applied force Fa you know, then mass and acceleration of A you know. So from this You can substitute those three values and find the value of FAB, force applied on B by A, and which will be equal to, again, action and reaction, FBA also. Okay, so substitute the values and find the answer. Let's go to question 34. Now come to question 35. A block of mass 15 kilogram is placed on a long trolley and the coefficient of static friction between the block and the trolley is 0.18. The trolley accelerates from rest with 0.5 meter per second square for 20 seconds. Then moves with a uniform velocity. Discuss the motion of the block viewed by a stationary observer and the observer moving with the trolley. Okay, so we can take a force F is equal to ma. Force F is equal to ma. So 15 is the mass and acceleration is 0.5. So you will get a force is around 7.5 Newton when you substitute the values. Now, friction acting on the block you can calculate. Friction is equal to mu mg. It is mu into capital R. Capital R is equal to mg. So, substitute the values, you will get around 27 Newton. Okay. So, imagine like this. So, you can have the block has an applied force 7.5 Newton, while the surface is able to provide 27 Newton friction. So what is the condition of the block? So friction is able to cancel and applied force is equal to 27 Newton. Friction is 27 Newton. If you apply a force more than 27 Newton, then only you can move the block. But at present, you can have the applied force is only 7.5 Newton. So the block will remain there. Okay. So for the stationary observer, as the friction is greater than applied force, the block will remain there. And for the observer moving with the trolley, for that observer also, okay, irrespective of friction, so he may not notice the friction, he is also running with the trolley. The block will remain there. In such a situations, usually we explain the block remains there because of a pseudo force. Okay, details you are not studying about pseudo force. Therefore, just understand that. Anyway, the block, whatever be the observer is in motion or observer is stationary, friction is greater than applied force, so the block will remain stationary there for both the observers. Okay, that's about question 35. Now, come to question 36. Go through the question. Here there is a truck. On the truck, there is a block of mass 40 kilogram. This block having mass 40 kilogram. Coefficient of friction is given 0.15. And the mass is placed 5 meter away. So that means this distance is around 5 meter. Okay, which means the block has to move backward 5 meter, then it will fall down from the truck. And the truck starts from rest, so initial velocity of the truck is 0. Okay, u is equal to 0, and it has an acceleration 2 meter per second square. Okay, so first of all, we have to calculate what is the net force acting on the block. How to find the net force acting on the block? Net force F net is equal to the force applied on the block, okay, that is due to the motion of the truck, due to the acceleration of the truck, we can take ma, where a is the acceleration of the truck, minus friction. Friction means, it is mu mg. When the truck is moving forward, a force is applied on it, okay, and opposite to that force you can see friction is acting, so net force will be applied force minus friction. And from there, okay, we can calculate the acceleration of the block. Remember, this is the acceleration of the block. How to calculate acceleration of the block? Okay, acceleration of the block is equal to F net divided by M. Acceleration of the, we can calculate. And remember, this is the acceleration of the truck. Okay, I will write T there to specify the acceleration of the truck. Now, you got the acceleration of the block. Use the formula S is equal to ut plus half at square. Use the formula S is equal to ut plus half at square, where S is the distance traveled by the block to fall. So how much it is? S you have to take as 5, because the block has to move 5 meter to fall. U is 0 plus half into acceleration of the block you have to substitute, and t square. Using this formula, find the value of t. Find the value of t. So what do you get? The time taken by the block to fall. Time taken by the block to fall, you got now. Then by then how much distance truck travel? That is a question. So the distance traveled by the truck is equal to, again you have to use the formula ut plus half at square, but this time here you want to calculate distance traveled by the truck. By then the block falls, what is the distance traveled by the truck? That's the question. So distance traveled by the truck, I have written as t here. U is again 0. U is 0. So half a t, acceleration of the truck, because distance traveled by the truck you have to calculate, and value of t you have to substitute from here. Then you will get the value of the distance traveled by the truck. You will get. Okay, so that's about the question 36. Now come to question 37. A disk revolves with a speed 33 1 by 3 revolution per minute and has a radius of 15 centimeter. 2 points are placed at 4 centimeter and 14 centimeter away from the center of the record. The coefficient of friction between the coins and the record is 0.15. Which of the coins will revolve with the record? Record, you know that before the time of tape recorder, there is a large disc with a contact, and the disc will rotate so that you can listen the music using megaphone and all. That is the arrangement. Okay, it's a megaphone. So here can take the disc, center of the disc. One coin is placed how much distance away? This is 4 centimeter. Another coin is placed 15 centimeter. This is 15 centimeter. Then the disc rotates. When the disc rotates, you can see these coins are in, we can say, they are in circular motion like this. So what will happen? For circular motion, centripetal force is required. Who provides centripetal force here? Friction provides centripetal force. Okay, that is the concept. Friction provides centripetal force. Now, if friction greater than required centripetal force, the coil will remain there. If friction less than required centripetal force, the friction will fail to provide the centripetal force so that the coil will be thrown away along tangential path. That is the concept. If friction is greater than centripetal force, friction provides necessary centripetal force so that the coil will remain there. If friction is less than centripetal force, then the coil doesn't have enough centripetal force, so that what happens? It will be thrown away along a tangential path. Okay. Now come to the bits. From the dead, friction you can calculate. Friction formula Fr is equal to mu mg. But in this case, you have to take, okay, you can substitute the value of mu and g. M is not given. Therefore, you just substitute the value of mu and mg and find the answer in terms of m. I think you will get the answer around 1.47 m. That much Newton is friction. That much Newton. That is friction. Find in terms of m. Okay. Now centripetal force. How to find centripetal force? What is that quantity given? Revolution per minute. One of the previous problems I told. Revolution per minute means it is frequency. So frequency nu is equal to okay. It is 33 1 by 3 revolution per minute. So that is 100 by 3 into 60 revolution per second. Revolution per second means it is SI unit, okay, hertz. That is frequency. Now centripetal force you have to calculate. Centripetal force for the first coil. We can take it as FC1 is equal to centripetal force formula. All of you remember M R1 is equal to 4 centimeter. Then 4 pi square nu square. 4 pi square mu square. So find the value. Here also answer you will get in terms of m because we don't know the value of m. Then the same way you calculate FC2 using the same formula m R2 is 15 centimeter, convert into meter, then 4 pi square mu square. Now you see here in which case centripetal force is less than friction. This condition is satisfied. That coin will remain there. And the other coin doesn't have enough centripetal force. Friction is not able to give required centripetal force. That will be thrown out in the tangential path. Okay. So you calculate both these quantities in terms of m Newton. Here also find the answer in terms of m Newton. Compare these three and see in which case this condition is satisfied. That coin will remain there. Now, next, motorcycle is driving in a vertical loop inside a depth well. In chapter work energy, you have studied vertical motion. What minimum speed required at the uppermost position? V minimum at the uppermost position we have calculated. It is under root GR. Okay, R is given, substitute the value of G, then you will get a minimum velocity to complete the loop. Now, next question 39. A 70 kilogram man stands in contact against the inner wall of a hollow cylindrical drum of radius 3 centimeter. Okay, so the situation you have to see here. There is a drum, radius of the drum is given. Then the man is standing and he applies force on the wall of the drum and the drum is rotating. He has to stay back there. Okay. Now, what happens there? If there is sufficient friction, okay, definitely he can stay back there. Friction should be sufficient. Friction here on the wall. When the drum rotates, he can stay back here by pressing on the wall, getting sufficient friction there. So we can have a friction F is equal to mu r. And in usual cases, the object is placed on a surface, force mg is acting downward, and reaction r is equal to mg acting upward. So far in all the problems we have taken there, wherever reaction r is there, we have taken r is equal to mg. But you remember, this is the difference in this question. This is not applicable here. Okay, so what provides him the reaction? Actually, what will happen here when the drum rotates? Okay, so he will get a centripetal force. So there is a centripetal force towards the center. And the reaction of the centripetal force we have to consider. Reaction of centripetal force we call the name centrifugal force. Centrifugal force. When the drum rotates, he is getting a centripetal force, and the reaction of centripetal force is known as centrifugal force. So that centrifugal force and centripetal force you have to consider. It is not mg downwards. Okay, it is centripetal force towards the center and centrifugal force in the opposite direction. Therefore, so like a mg and a reaction rmg here, formula will be same. So here mu into r you have to calculate m r omega square. M r omega square. Now this m r omega square, this is the friction. Okay, omega is the angular velocity. Here also given frequency you can convert into revolution per second. Then omega is equal to 2 pi nu formula you have to use. Oh, sorry, no need to take that weight because we want to calculate omega. I think what minimum rotational speed of the cylinder. So omega only you need to calculate. So this one is not a matter. Okay. So then this friction should balance the weight of the man, mg. So because of friction only he can stay back here. That means his body weight should be balanced by friction. So mu mr omega square is equal to mg. M and m cancel. Simplify the equation and find the value of omega. Then you will get for what velocity, for what minimum velocity the cylinder has to rotate so that the man remains stuck there without falling. Otherwise, if this friction cannot balance his weight, means what happens? He will fall. So what should be the minimum angular velocity omega so that the man can remain there? Okay, you can find out using this concept.